Yeah. So let's start. So good evening once again to both of you. And we are dealing with the alcohols, phenols, and ethers lesson, right? So it's been okay. No problem, my dear, no problem. So we have all the recorded classes in Navanti Live 2 channel. So you can go through that and take the notes of the chapters which we have done in the previous sessions. Got it? So that you can understand what we are doing. So we have completed some 4 to 5 lessons so far. You can go through the channel and have a look on it. Clear? So don't worry. So moving ahead with today's session. So before Diwali, we have did this, no? So let me just recall what we have done in the previous class, and then I will move on to the today's session. Got it? So majorly, if you see in the previous class, I have dealt with the preparations, mostly the preparations and the properties, right? Not much about the properties. We have dealt with the preparations of alcohols. Okay. So there were 3 methods of preparation of alcohol. So the first method of preparation of alcohol is from alkenes. Okay. So from alkenes, we have prepared using 2 types, 2 ways. The first one is by acid catalyst dehydration. So using an acid and water, we have added the water molecule to the alkene and we have prepared the alcohol. And the second method is hydroboration oxidation. Okay, so where we used B2H6 and H2O, H2O2 as the reagent. This is the first method of preparation. The second method of preparation is from the carbonyl compounds. Carbonyl compound means from aldehydes, from ketones, from carboxylic acids. So from those compounds we have prepared. So if I want to get the alcohol from aldehyde, then I have to use such kind of reagents, which you can see on the screen. For you see there hydrogen in presence of nickel, palladium or platinum, and lithium aluminum hydride, sodium borohydride. Okay, it's up to you. So aldehyde will be converted to a primary alcohol. Okay, aldehyde will be converted to a primary alcohol by using the reducing agents given in the list. And the ketone can be reduced to secondary alcohol using the same reagents. Got it? So this is the second method of preparation of alcohol from carbonyl compounds. Now the third method of preparation is from Grignard reagent, right? So there were 3 methods and this is the last method. Preparation of alcohols from Grignard reagent. Okay. So what is a Grignard reagent first of all? What is a formula for Grignard reagent? Can you guys give a try? What is the formula for Grignard reagent? Have you heard of this term before? Grignard reagent? JNB Vijayanagram students? What is the formula for Grignard reagent? Okay, I will give you the formula. So it is RMgX. Okay, RMgX is the formula. And here the R, which is the alkyl group, that gains the partial negative charge and magnesium will have the partially positive charge. So R group can be alkyl group or aryl group. It can be aromatic compound or an alkylic system. Okay. And X is the halogen. You all know halogens are chlorine, bromine, iodine. Got it? So it can form. So Grignard reagent can form primary alcohol, secondary alcohol as well as tertiary alcohol. So all three types of alcohols can be prepared using Grignard reagent. Okay. So now let's see the reaction. So let me take one compound. Okay. So we are going to prepare alcohol from Grignard reagents using aldehydes and ketones only. Okay. So first let me take an aldehyde, which is formaldehyde. If this formaldehyde means we have two hydrogens, HCHO, okay? So first of all, this has to be treated with Grignard reagent RMGX. Then it has to be hydrolyzed with water in presence of acid. So H2O in presence of H+. So these two reagents will convert this formaldehyde to primary alcohol. Okay. So from formaldehyde, we will get primary alcohol. So how I am saying it is a primary alcohol? Because it has RCH2OH. RCH2OH. Okay. So now to prepare the secondary alcohol, what I have to do? I have to take some other aldehydes than formaldehyde. Okay. You have to take some other aldehydes other than formaldehyde. So by taking some other aldehyde and having the same reagents, we will get secondary alcohol. Okay. So where we have two R group and CHOH will be the component. And to prepare the tertiary alcohol, we have to take a ketone. So ketone means both groups will be alkyl group, right? So both are alkyl groups. And if you use the RMGX and H2OH+, it will give you tertiary alcohol where you have only COH component. Got it? So this is the reaction. So now I am going to give you the mechanism to get this product from the corresponding reactants. Okay. So let me give you the mechanism to prepare the primary alcohol first. Okay. So to form the primary alcohol, initially I have to take a formaldehyde. Okay. So oxygen end is the negative end and carbon is the electrophilic part, right? So it will have positive end. Now, first of all, this has to be treated with RMGX. So what will happen, the negative R group will go to the positive carbon end of the aldehyde and MGX will go to oxygen. MGX will go to oxygen and they will lead to this type of product. Got it? So this is the carbon. A new bond has been formed between the carbon and the alkyl group and the MGX will go to the oxygen. So then what we have to do? We have to use H2O and H+. Okay. So now this acid hydrolysis will convert or this OMG bond will get broken down and from H2O, H will go here and OH will go here. Okay. So it will lead to this product and the remaining, this is the primary alcohol and the MgXOH. So this will form as a byproduct. Okay. So this is how we have to prepare the alcohol from aldehydes. Got it? Not only from aldehyde, from carbonyl compounds, that is aldehydes and ketones. Okay. So now if I have to prepare secondary alcohol, then what I have to do? I have to take some other aldehyde, right? Some other aldehyde means one will be hydrogen and the other one will be the R group. Like it may be CH3 or C2H5, methyl, ethyl, it can be anything. Okay, so what I have to do? I have to add RMGX. So R has to go to carbon and MGX has to go to oxygen. Okay, and they will form an addition product which is called as an adduct. And next it has to be treated with acid in presence of water. The OMG bond will break, H will go here and OH will go here. We will get the secondary alcohol, CHOH. Okay. And MgOHX is the byproduct. Got it? Now, to form the tertiary alcohol. To form the tertiary alcohol, we have to take a ketone, right? So here I have taken acetone. Acetone means two alkyl groups will be CH3. Both the groups will be CH3. So first add CH3MgX, methyl magnesium halide I have taken. So the R group, this is the R group of Grignard reagent, right? So that has to go to carbon and MgX has to go to oxygen. Okay, so we will get this type of adduct and on treatment with H2O, You have to do the same process. Add the molecule like this, and you will end up with the tertiary alcohol with the removal of MgOH(X). Clear? So is it clear for all of you? Able to understand? So JNV Vijayanagaram students, can you able to understand? So this is all about the preparation of alcohols. Do you have any doubts in the preparation of alcohols? Shall we go ahead with the preparation of phenols? Shall we go ahead with the preparation of phenols? Yes. Yes. Okay. So let's go ahead with the preparation of phenols. So the first method of preparation of phenol. So before moving on to the first method of preparation, I would like to give some information about the phenol. Okay. So the formula for phenol is C6H5OH, right? C6H5 and OH. So one phenyl ring which is attached to OH. This is also called as carbolic acid. Phenol is otherwise called as carbolic acid. And it is first of all isolated from coal tar. It was first isolated from coal tar. In the laboratory, we can prepare the phenol from the benzene derivatives, like from chlorobenzene, from bromobenzene. So from those compounds, you can prepare the phenol. Okay. So it is isolated from coal tar and it can be prepared in the laboratory using the benzene derivatives compounds, and it is otherwise called as carbolic acid. Okay. So now let's go ahead with the first preparation, that is from haloarenes. What is meant by haloarene? The halogen which is attached to aromatic ring is called as haloarene. The very simplest example is chlorobenzene. Okay. So first of all, this chlorobenzene has to be treated with one compound, and that compound is a base. Okay. So that base is sodium hydroxide. And we have to do this reaction at a very drastic condition. Drastic means at a very high temperature and high pressure. Okay. At 623 Kelvin and at 300 atmospheric pressure, we have to do this. So if you do so, HCl has to be removed and ONA will go and take the place of Cl. Okay. HCl will come out. HCl will come out and ONA will go and get attached to the ring. And this is called as sodium phenoxide. Now the sodium phenoxide in the second step has to be treated with HCl. Okay. So if you treat this with HCl, NaCl will be removed and H will go and get attached with oxygen. So we get a phenol. Okay. So first it has to be treated with a base, then it has to be treated with an acid. Got it? This is actually the substitution of chlorine from benzene ring. Substitution of chlorine by OH. Okay. And this reaction, this substitution on the haloarene is not that much easy. We have studied the reason for this statement in the previous lesson itself. Right? There were 4 reasons behind this. You can go through the lectures of the haloalkanes and haloarenes to get the answers. Okay. Substitution of the OH group of this to the Cl group is difficult. So we have to do this at a very drastic condition at high temperature and pressure. And we also have one name for this process, and that is called as Dow's process. Okay. So it is actually the nucleophilic substitution reaction, where the Cl nucleophile gets substituted by the OH nucleophile. Okay. So this is the first method of preparation of phenol from haloarene. Okay. So now going ahead with the second preparation. So do you have any doubt in the first preparation, students? Shall I go for the next? Shall we see to the next one? Do you have any doubt in the first reaction? Am I audible? JNB Vijayanagaram, am I audible? Okay, the second method of preparation is the preparation of, okay, thank you so much, dear students. So second method is from benzene sulfonic acid. So we are going to prepare from benzene sulfonic acid, but to prepare the benzene sulfonic acid, we need benzene. Okay, so first of all, the benzene has to be treated with oleum. Oleum means it is called as fuming sulfuric acid and its formula is H2S2O7. Okay, so which is written as H2SO4 plus SO3. Okay, this is called as fuming sulfuric acid and this is called as oleum. Okay, so and from this reagent, we will get an electrophile and that electrophile is SO3H plus. SO3H plus and this SO3H plus will go and get substituted in the benzene ring and they give benzene sulfonic acid as a product. Okay, so now this has to be treated with the base and then with an acid so that the SO3H gets replaced by the OH. Got it? Very simple and easy. This is the second method of preparation. All right. So moving ahead with the third preparation, it is from diazonium salts. So what is meant by diazonium? Azo means nitrogen. Okay. Diazonium means N2. Diazonium salts means N2 plus containing salts. Okay. So to prepare the diazonium salts, we need one compound and that compound is called as aniline. Okay. If I have NH2 in the ring, it is called as aniline. So aniline has to undergo one reaction where NaNO2 and HCl will be used. Okay. So this mixture is called as nitrous acid mixture. This mixture is called as nitrous acid mixture. Okay. So this nitrous acid mixture will convert NH2 group into N2Cl group. It will convert NH2 group into N2Cl group. Okay. And this is called as benzene diazonium chloride. Okay. Now in the next step, it has to be treated with warm water so that the N2Cl group will be converted to OH. Nitrogen N2 will come out and HCl will come out and the remaining OH from water will go and get attached with the ring to give the phenol. Okay. So we are getting benzene diazonium chloride from aniline, right? So the first step of reaction is called as diazotization. Okay. And we have to do this first step at very, very low temperature. That is between 0 to 5 degrees Celsius. Okay, between 0 to 5 degree. In terms of Kelvin, if I have to say, then it is between 273 to 278 Kelvin. So only at this low temperature, you can convert NH2 group to N2Cl group. Okay, so the first step is called as diazotization, which takes place at very low temperature and with the help of nitrous acid mixture. Got it? This is the third method of preparation. Now coming to the fourth method of preparation, it is from cumene. So what does cumene? Isopropyl benzene is called as cumene. Isopropyl benzene is called as cumene. So you see here, we have a benzene and we have an isopropyl group attached to this cumene. I mean benzene. Okay. So cumene is otherwise called as isopropyl benzene. So this isopropyl benzene or cumene has to be treated with oxygen. It has to be treated with oxygen. So this oxygen, we have two O, right? So that will go and get inserted between this CH. that will go and get inserted between the CH. Okay. So, and it will lead to this type of product, cumene hydroperoxide product. Now, this cumene hydroperoxide has to be treated with acid in presence of water, and they will eliminate the CH3COCH3 out, and OH is there, right? So, this OH will come and get attached with the ring. Okay, CH3COCH3 will come out. Okay, CH3COCH3 is actually acetone. So, we are getting acetone and phenol as the product from this reaction. Got it? Since we are using an acid in this reaction, this is called as acid catalyzed reaction. And from this preparation, the acetone is forming, right? So the yield of acetone, the formation of acetone is very, very good. Okay, so we can get a good amount of acetone from this reaction along with the phenol. Okay, so these are the 4 methods of preparation of phenol. Okay, let me summarize. Let me summarize all the 4 reactions for you so that you can understand. So what is the first method? From haloarine. Okay, so we have used a base and an acid to get the phenol. And the second method is from benzene sulfonic acid, and that has been formed from benzene using oleum. Okay, and the third is using cumene, and the fourth is using aniline. Got it? So these are the 4 methods of preparation of phenol. So do you have any doubts in all these 4 reactions? All the 4 reactions are very, very important. Okay, so if you have any doubt, you can ask me now. If you have any doubt, you can ask me now. From haloarine, from benzene sulfonic acid, from aniline, and from cumene. Okay, any doubt you have? Shall we go ahead with the properties? Shall we go ahead with the properties? Any doubt from the preparation? Shall we go ahead with the properties, students? Okay, let me go ahead with the properties. Properties of alcohols and phenols. Okay, so the learning objectives are, first of all, we are going to learn the physical properties, and next is the chemical properties. So coming to the physical properties of alcohols and phenols, you see here, I have taken an aromatic alcohol and an aliphatic alcohol. Okay, so the aromatic ring or the R group, which is an alkyl chain, so that we have, and in both the components, the OH is same. Okay, so this is the OH group, and this OH group is responsible for most of the physical properties and the chemical properties in the reactions. Okay, and this alkyl group or aryl group is responsible for the modification in the properties. Okay, if you want to make some modification in the chemical property or some physical property, this will be responsible, and for most of the reactions, OH group is responsible. Okay, so now I'll go ahead with the first physical property, which is called as boiling point. Boiling point of alcohols and phenols increases with increase in the number of carbon atom. That is, if the number of carbon atoms increases, boiling point also will increase. For example, So let me take a 2 carbon containing alcohol. Okay, ethanol. CH3, CH2OH. And next I am going to take a 4 carbon containing alcohol. And this is called as butanol. So in which case the boiling point will be more? Can you tell me? In the first case or in the second compound? In the first compound or for the second compound? Which compound will have the highest boiling point? Can you tell me the answer for this? Janvi, Vijayanagram students? Can you able to give me the answer for this? Compound 1 or compound 2? Okay, it is compound 2. All right, because it has more number of carbon atoms. So the boiling point of the second compound will be more. Got it? So just only one simple relation. If the number of carbon atoms are more, boiling point will be more for that compound. Okay. So now we will go for the second case. Okay. Suppose if I have some branches, like for isomers, if you take, isomers will have same molecular formula, means they will have same number of carbon atoms, right? So in that case, how to find out the boiling point? Which one will have the highest boiling point? So for that, the boiling point decreases with increase in the branching. Okay. So if the compound which has more number of branches will have the least boiling point. Okay. So I will make you understand by giving one example. So here you see we have 1, 2, 3, 4, 5, 6 carbon atoms in this compound. And looking to this, here also we have 1, 2, 3, 4, 5, 6 carbon. Means both has 6 carbons. Okay. But in the first case, we have a straight chain. All the carbon atoms are arranged in a straight chain manner. And in the second compound, we have some branches. Okay. So if the branches are more, boiling point is less. So in this case, the branches are more. So the boiling point is very, very less. Okay. So the second compound has the low boiling point value. All right. So the first relation is, if the number of carbon atom is more, boiling point is more. For isomers, if the branches are more, boiling point is less. Inversely proportional relationship. Okay. Next one. Boiling point of alcohols and phenols are higher than hydrocarbons, ethers, haloalkanes and haloarenes of comparable molecular mass. So let me take an alcohol whose atomic mass, molecular mass is 46. And next I'm going to take an ether which has mass 46. And next I'm going to take an hydrocarbon alkane which has the molecular mass is 44. Okay. So if I compare an alcohol, ether and hydrocarbon, okay. So which one will have the highest boiling point? Boiling point of alcohols and phenols will be higher. Okay. So let me give you the value. So alcohol is having 351 Kelvin and ether is having 248 Kelvin and the hydrocarbon is having 231 Kelvin. Okay. So the molecular mass of all the three compounds looks similar, but the alcohol is having the highest value. Okay. So the reason, what is the reason for this alcohol to have the highest boiling point value? Okay. The reason is hydrogen bonding. It is because of the hydrogen bonding that an alcohol can make. So what is hydrogen bonding? So this is the first molecule of alcohol and this is the second molecule of alcohol. And between the two molecules, we have an hydrogen bonding, right? Oxygen of one molecule forms the bond with the hydrogen of the other molecule. And this is called as hydrogen bonding, okay? And the third molecule can come and form the bond like this, okay? And this kind of red color dashed bond is called as hydrogen bonding in alcohols. In case of phenols also, we can do it in the same way. C6H5OH with another C6H5OH can form the hydrogen bonding. So this hydrogen bonding is strong. So to break all the hydrogen bonding for alcohol and phenol, they take the high temperature. Okay, but such kind of hydrogen bonding do not exist in case of ether or hydrocarbon. Okay, so that's why they have very low boiling point and alcohols are having high boiling point. Okay, so this is all about the first physical property called boiling point. The second physical property is solubility. Alcohols and phenols are soluble in water due to hydrogen bonding again. The reason again for the highest solubility nature is hydrogen bonding. So let me give you the formula. So this is the alcohol. Okay, propanol, where we have 3 carbons. So if I put this propanol inside the water, the oxygen and hydrogen end of the alcohol is forming the bond with the water molecules. Okay, forming the bond with the water molecules. So what will happen? They will go and form the hydrogen bond and they will break the water molecule. This bond will get broken down. Okay, bonds will get broken down and the propanol can get dissolved inside the water more easily. Okay, because of the formation of hydrogen bonding. And this solubility decreases with increase in the size of this alkyl group. So if I am increasing the alkyl group size, this is the alkyl group. Okay. So if I increase the number of carbons, means if I am increasing the size of the alkyl group, the solubility will decrease. Okay. So this is the hydrophilic end. Hydrophilic means water loving site. So the water loving end and this is the water hating end. So if I increase the length, so here I have 1, 2, 3, 4, 5, 6 carbon and here I have only 2 carbon. And in the first case, the length is more and the second case, we have only 2 carbon. Smaller hydrophobic part and here bigger hydrophobic part. So the one which is having the smaller alkyl group or smaller hydrophobic part will get dissolved more easily. So highest solubility is for ethanol and the solubility is very less for hexanol. Got it? Solubility of all the alcohols inside the water is more, but if the length increases, solubility decreases. Okay. So going ahead with this concept, we will solve one question from the physical property. Arrange the following compounds in order of their increasing boiling point. So we have 6 compounds. Okay. Pentan 1-ol, butan 1-ol, butan 2-ol, ethanol, propan 1-ol and methanol. So what we have to do? How to arrange these compounds in the increasing order of boiling points. So we know that the boiling point increases with increase in the number of carbon atom. And if the carbon atom remains same for 2 compounds, then the boiling point decreases with the increase of branching. So these are the 2 relations we know. So using these two relations, we can get the correct order. Okay. So first of all, you have to check for the first rule. Okay. You have to check for the first rule. If the number of carbon atom is very less, boiling point is very less. Okay. So if you use this, relation, you will get methanol will have the least value compared to ethanol. Because here we have 1 carbon and here we have 2 carbon. And next 3 carbon system will come. Propan 1-ol will come. And next we have 4 carbon containing system. But we have 2 4 carbon containing compound. Butan 1-ol and butan 2-ol. Okay. So for this type of case, you have to go for the second rule. The one which is having the branch, will have the least boiling point compared to the other. So that's why butan 2-ol is having the less value compared to butane 1-ol. Okay. And lastly, we have a 5-carbon containing system, pentane 1-ol. Pentane 1-ol will have the highest boiling point value compared to the others. Okay. So this is all about the physical properties of alcohols. Okay. And phenols also. Boiling point and solubility. Okay. So now let me go ahead with the chemical properties of alcohols and phenols. So first of all, alcohols are versatile compounds. Versatile means it can act as a nucleophile as well as an electrophile. Okay. So the reactions in which the alcohols are acting as an electrophile will be classified like this. First, it is classified first on the basis of the breakage of OH bond. Okay, so the bond between OH will break. This is the alcohol, and the bond between OH will break. And all the reactions which involves the breakage of OH bond will act as a nucleophile. Okay, in all those cases, the alcohol will act as a nucleophile. And if the bond between carbon oxygen is break, if the bond between carbon oxygen is getting broken down, then all those reactions will fall under the electrophile category. In all those reactions, alcohol will act as an electrophile. Okay. So first, let me go to the reactions involving cleavage of OH bond. Reactions involving the cleavage of OH bond. So here the first reaction is about the acidity of alcohol. And secondly, we will discuss about the acidity of phenols. And thirdly, I will discuss about the esterification. So in all these three reactions, the OH bond will get cleaved. Okay. So let me start with the first reaction to study the acidity. And the reaction is the reaction with metals. The reaction is with metal. So take an alcohol, treat it with some metal. I have taken sodium metal here. So what will happen, you know, the OH bond. So it will get cleaved. Okay, it will be broken down. So I will take 2 moles of alcohol and the OH bond will be broken down and sodium will go and take the place of hydrogen and 2 hydrogen will come out. So we get sodium alkoxide. So for example, if I take an tertiary butyl alcohol and treat it with aluminium metal, the OH bond will get cleaved and it will lead to this type of product. Aluminium tertiary butoxide. Aluminium tertiary butoxide with the 3 moles of hydrogen coming out. Okay. So this is, if hydrogen is coming out, if a compound is losing the H plus, then that compound is an acid, right? Clear? So we are taking hydrogen out from the alcohol. So this shows the acidity of alcohols. Okay, the reaction with the metal shows the acidic nature of alcohols. All right. Now, alcohol can act as a Bronsted acid also. What is a Bronsted acid? Bronsted acid means the proton donors are called as Bronsted acid. So this is an alcohol and H plus is the proton. If I treat this alcohol with the base, okay, B minus is a base. So that will go and abstract the hydrogen. That will go and abstract the hydrogen. Okay, and the electrons which are present there between the oxygen and hydrogen bond will get shifted to oxygen. So here, alcohol is losing the H plus. So it is a Bronsted acid here, and it will lead to the conjugate base RO minus and BH, which is conjugate acid. Proton donors are called as Bronsted acids, and alcohol is acting as a Bronsted acid here. Got it? So this acidity of alcohol is mainly due to the polar nature of OH bond. So if I take methanol, we have oxygen and hydrogen and CH3 in the compound. If I take OH bond, Hydrogen is coming out from the alcohol so easily. The reason they are trying to say is the polar nature. So what is meant by polar nature? So they are forming dipoles. So how do they form a dipole? Oxygen is more electronegative compared to hydrogen. So oxygen will try to gain the shared pair of electrons towards itself. Okay, and it gains the partially negative charge. It is actually wrong here. It will be partially negative and hydrogen will get partially positive charge. Okay, so they form plus minus kind of poles. So the bond is polar now. So because of this, because of the ability of pulling the electron towards itself for oxygen, so hydrogen is leaving the compound so easily. Okay, if hydrogen leaves out, it shows the acidic nature of the alcohol. Okay, but we have different types of alcohols, right? Methyl alcohol, primary alcohol, secondary alcohol, tertiary alcohol. So among these types of alcohol, primary alcohol is more acidic. What is the formula for primary alcohol? RCH2OH. So here this alcohol is more acidic because we have only one R group. R groups are electron donating groups. So we have only one person to donate the electron. And if I take the secondary alcohol, we have two R groups. And in case of tertiary, we have three R groups. If more people are helping you, you will become more electron rich, right? So the carbon will become more electron rich here. And it will not allow this hydrogen to come out. Okay, it means that it is very least acidic. Got it? So the R group is decreasing the polarity of OH bond. If the R group is more, then the OH bond polarization is less. So the hydrogen cannot come out easily from the tertiary alcohol. Okay, clear? So primary alcohol is more acidic than secondary alcohol, then tertiary alcohol. Got it? So next we will talk about the acidity of phenols. Acidity of phenols. Here also I am going to take the reaction with metal. So you all know that C6H5OH is phenol and I am going to treat this phenol with the sodium metal again. So 2 moles of phenol will react with 2 sodium. Here also the OH bond will be broken down and we will get sodium phenoxide compound. Okay, clear? So sodium phenoxide means O minus Na plus. So this phenol will form O minus and H plus actually. So this phenol will form O minus and H plus and these two, phenol and phenoxide ion. This is phenol and this is phenoxide ion. Phenoxide ion. So these two are in equilibrium with each other, but phenoxide ion is more stable. If that is more stable, then the forward reaction is more stable. Okay. So if it is more stable, then the forward reaction is more stable. Got it? And H plus that is forming is also is at very high concentration. Okay. So only if phenol loses H plus, it forms the phenoxide ion and that is getting more stable. Right? It means that phenol is more acidic in nature. It means that phenol is more acidic in nature. Since this phenol donates H plus from it, it is called as an acidic compound. Okay. So phenoxide ion is more stable due to resonance. What is meant by resonance? The electron delocalization is called as resonance. Okay. So phenoxide ion is more stable due to resonance and that's why phenols are more acidic compared to the other alcohols. Okay. So in case of alcohol, if you see, we have, if H plus is coming out from alcohol, we are getting RO minus ion, right? Alkoxide ion. And here the negative charge is localized. Negative charge is localized only on oxygen. But if you take phenol and form the phenoxide ion, this negative charge is getting delocalized over the entire ring, right? We also studied that it is more stable due to resonance and this reaction is more favorable. So what will happen, the phenol getting converted to phenoxide ion reaction will be more fast since the H plus concentration is very high in that case. Okay. So, but in case of, and the phenol will be more acidic. Phenol will become more acidic. But here, this reaction is very slow due to the formation of the less amount of H plus. Got it? So, the reason is the negative charge is localized on oxygen. Here, the negative charge is delocalized on oxygen and with the carbons in the ring. Okay. So, H plus comes out easily from phenol. The reaction is very fast. And here the H plus is coming out very slowly. Okay. And the concentration of H plus is also very low. So, the reaction is getting very, very slow. Got it? So, now let's study about the acidic nature of substituted phenol. What if some substitution is there on the phenol? So, we can have two different types of compounds, okay, substituted on phenol. One is electron withdrawing group and the other one is electron donating group. So, who are the electron withdrawing groups and what is the effect of having electron withdrawing groups on the ring? So, first of all, the list is NO2, COOH, CHO or COH and CN. All these are electron withdrawing groups. Nitro group, acid, aldehyde, cyano. Okay. So they show negative inductive or negative resonance effect. And electron donating, they are OH, OR, NH2 kind of compounds. And they show positive inductive or positive resonance effect. Got it? So if electron withdrawing group is present on the ring, okay, if the electron withdrawing group is present on the ring, then it will increase the acidic nature. It will increase the acidic nature. Electron withdrawing groups will increase the acidic nature because they will withdraw all the electrons from the ring and make it more electron deficient. So it increases the acidic nature and electron donating groups will keep on donating the electrons to the ring. So they decrease the acidic nature. Okay, the ring becomes more electron rich by taking the electrons from these donating groups and it becomes more electron rich and the acidity will decrease. Okay. Electron withdrawing group increases the acidity. Electron donating groups decreases the acidity of alcohols. Okay. So if I compare, let me take, this is the phenol and this is the NO2. Okay. And secondly, I am going to take benzene. And not benzene, let me take phenol. And thirdly, I am going to have phenol attached to CH3. So here if you see, NO2 is an electron withdrawing group and CH3 is an electron donating group to the ring. So what will happen? Electron withdrawing will increase the acidity. Okay, so the first compound will be more acidic. Then if you compare phenol and methylphenol, phenol will be more acidic. Because in case of methylphenol, we have electron donating group and that makes the ring electron rich. Okay. So it will be more electron rich and decreases the acidity. Clear? So this is how they will give you the compounds and ask you to find out the correct order of acidity. So for that, you have to use this concept. Okay. So finally, let's study about the esterification reaction. So esterification reaction means the formation of esters from different compounds. The different compounds are carboxylic acids, acid chlorides, or acid anhydrides. So if any of these three compounds is treated with alcohol or phenol in presence of catalyst, they form ester. Okay. So first let me take an carboxylic acid. RCOOH is called as carboxylic acid and ROH is alcohol. So if these two are getting reacted in presence of H+, they do form water and ester. Ester means RCOOR, right? So here the OH bond will get cleaved, okay, and here OH will come out. RCOR plus H2O. Next, if I take acid chloride means RCOCl. So here with alcohol and acid or a base here. Here the catalyst is a base, pyridine is a base. And they form ester and HCl. So OH bond will come out, will break, HCl will come out. Okay. And thirdly, with acid anhydride. So this is acid anhydride and they lead to the formation of ester and acid. So you all know it is R dash, C double bond O, C double bond O and R dash, right? So this is acid anhydride. If it is treated with alcohol, OH bond will come out. Okay, so this group will be eliminated. So this group will be eliminated. So we have R dash COOR. One of the component is ester. And the one which is getting eliminated, this group, R dash COOH. This is R dash COOH. Carboxylic acid is coming out as the other product. Okay. So from this reaction, we are going to study one more with the same mechanism, and the name of the reaction is acetylation. So it means introduction of acetyl group in alcohol or phenol. Okay. So basically this acetylation is used for the synthesis of aspirin, and you all know aspirin is used for treating the fever and the pain. Okay, so medicine. So first of all, I have to take a compound, and the compound is salicylic acid, and it is treated with acetic anhydride. Okay, and in presence of H plus. I already told you what is acetic anhydride, right? CH3, CO, O, CO, CH3. So and what will happen? The OH bond from salicylic acid will come out, and it will come out with the RCOO part, and the remaining CH3CO will go and form the bond with oxygen. CH3CO will go and form the bond with oxygen, and the CH3COOH is coming out from the reactants. Got it? And this product is called as aspirin, in which we have an ester linkage, RCOOR. Okay, this is one R group, this is one R group, this is one R dash, so R dash COOR. Okay, this is an ester. Okay, ester from acetic anhydride and alcohol. All right. So this is all about the esterification, acidity of alcohols and phenols. So let me summarize the properties. So first of all, we have studied about the boiling point. Boiling point of alcohols and phenols were very high because of hydrogen bonding, and the solubility of alcohols and phenols in water is also very high due to hydrogen bonding. And we have studied that alcohol can act as a nucleophile in case of OH bond breakage. And under this OH bond breakage category, we have discussed about the acidity of phenol, alcohol, and esterification. And talking about the acidity of alcohol, primary alcohol will be more acidic than secondary than tertiary. And in case of acidity of phenol, phenols are actually more acidic compared to alcohol. And if electron withdrawing group is present in the ring, it increases the acidity. And if electron donating group is present in the ring, it decreases the acidity, right? And talking about esterification, we have studied three reactions. One is carboxylic acid with alcohol, and the other one is acid anhydride with alcohol, and the one more thing also we have studied. Okay, acid chlorides with alcohol. So all these three reactants with alcohol and with the H plus, they led to the formation of ester. Okay, so this is all we have done in today's session under the properties. And before that, we have discussed about the preparation of phenols, in which we had 4 preparation. And before that, 1 preparation of alcohol, that is from Grignard reagent, we have discussed. Okay. So I hope this session is very useful for all of you. And if you have any doubts, you can come up with your doubts in the next class. Okay. So thank you so much for attending the lecture. Till then, take care. Bye-bye. See you.